Okay, ladies and gentlemen, we are talking about lesson 5.5. Lesson 5.5 is inequalities that are involving the absolute value sign. So what does an inequality involving the absolute value represent? That's the big question for today. So very similar to when we solved absolute value equations, absolute value inequalities have the same type of a process. If you recall, we created two situations when we were solving absolute value equations. We will do the exact same thing here when we are solving the absolute value inequalities. So we will change this inequality into two situations, and this will remove the absolute value bars. N minus 3 is less than or equal to 12, and n minus 3, and we're going to change the sign, is greater than or equal to a negative 12. Now the reason why we do that is because inside here this could be a negative, and to make this a positive we have to divide by a negative, therefore changing the inequality. So if we solve both of these, we're going to add 3 to all sides. Now we can do this all in one step like you can see me doing, and we're going to now have our answers where n is less than or equal to a 15 and n is greater than or equal to a negative 9. Now our job, like always, has been to graph these things. So if we have a negative 9 and a 15, so I have my two lines here at negative 9 and at 15, just to graph them easily. These are both going to be filled in circles. And since the 9s, we are looking at n is greater than or equal to a negative 9, and n is less than or equal to a 15, we're going to connect the lines here. Now this is an AND situation, an intersection. This symbol, the less than or equal to, will help us to determine that we know that we're looking for an intersection. So let's try again here. In fact, I'm going to pause for a second and get rid of this. All right, back at it. We are solving the example 2. It's the very same situation as what we just got done going over. Our job is again to create the two situations and solve. So we have the two situations where x plus 6 is less than a negative 8 and x plus 6 is greater than a positive 8. Now in these two situations, if we think about this, is it actually possible to do this problem from the beginning? Can the stuff inside here become a negative? And I wanted to rewrite this just so that we understand this. The answer is no. This is a no solution. It's not possible for me to have a situation in which stuff inside at the very beginning of the absolute value of something cannot be negative. So that's why we have a no solution or an empty set from this specific problem. All of these symbols mean no solution or an empty set. So let's keep on moving as we are getting more and more intelligent as the moments go on. So previously, when the symbol was going the other way, the less than symbol, we had intersections. Now with a greater than symbol, we are changing this to a union like we did in part 2 of our 5.4. So if we solve this, we're looking for a union. 3y minus 3 is greater than 9, and 3y minus 3 is less than a negative 9. So we're looking for a union, which means either one of these can be true. So solve it. We're going to add 3, add 3, add 3, add 3. And we're doing this again because we want to get the y by itself. We're undoing the order of operations. 3y is greater than 12. 3y is less than a negative 6. Now we divide by a 3 to get the y's by themselves. We find out that y is greater than 4 and y is less than a negative 2. So if we were to graph that, we have a negative 2, we have our 4, open circles at both of these things. Y is greater than 4 goes this direction. Y is less than negative 2 goes this direction. So our numbers that could work are any number that is less than 2 and any number that is greater than 4 if we were to plug it back into our inequality. All right, let's keep it cooking. Same idea for the next problem. Your two situations. Again, this is a union because of our symbol. 2x plus 7 is greater than or equal to a negative 11. Now, folks, if we were to remember what we did with our last problem, in our previous problem, let's go back to it, I'll show you, just so that we're all on the same page here, if I can get back there. Because x plus 6 cannot be less than a negative number, because x plus 6 cannot be negative in its own right, that's why we have no solution. If we go back to this problem, a 2x plus 7 greater than or equal to a negative number, that always has to be true. So every time we have a union and there's a negative out here, our two situations don't matter anymore. What we're going to end up having is all solutions are possible because what's inside here has to be a positive number, therefore it must always be greater than this negative 11. So this will be in all solutions. So the way that you would draw that to graph it is you would just make a number line. Maybe you choose 2, maybe you choose 7 or whatever your numbers are, and you're just going to fill in all of them. They go all directions, it's all solutions, due to the fact that it's always going to be greater than a negative 11. There's no possible way that the absolute value of something can be negative. So it's going to be greater than a negative number at all times. So with this problem, our job is to find the absolute value inequality for the graph. So the easiest way to go about this is to find the total distance between the 2 points, because we're looking for the distance from 0. And sometimes that distance from 0 gets shifted one side to another side. So if we count from 3 to 2, 1, 2, 3, 4, there's 8 spots here. So from here to here is 8 spots. That means halfway is at negative 1. So we're looking for 4 spots for each spot from this middle point. So our absolute value of x, and because this is a minus 1, we're going to do the opposite, plus 1 is going to be, now because they're facing the opposite directions, it's going to be greater than and not equal to, because we have open circles, of 4. So the distance was 4, that's where this 4 comes from. The minus 1 turns into plus 1 because we're on the inside of the absolute value. So this is how we create the absolute value inequality for a graph. So if we are given the graph, we can determine all that information just by counting. How far is it between each point? Divide it by 2. That's going to be what's on the outside. Where the middle point is what my x plus 1 or what my x minus 1 or whatever the number might be. So this is how we create the graphs for absolute value inequalities. Here's your assignment for this lesson. Please do your best. Thanks for paying attention. Burma Nation signing off.